All right, here's the 4.5 homework assignment. We're dealing with L'Hopital's rule. In this first question, and frankly in most of the questions, what you want to do is look at the limit you're presented with and see if it's an indeterminate form. And if it is an indeterminate form, apply L'Hopital's rule. And that will give you another limit. And see if that limit is an indeterminate form. If so, apply again. If not, evaluate that limit. That's the basic outline for all of these problems. In this first problem, I think you'll see they provide you with an indeterminate form. You use L'Hopital's rule once, and I think you'll see that provides you with a form that is no longer indeterminate, so it's a limit you can evaluate. Evaluate it, get that answer, put it here. That's different than question 2. In question 2, you'll start out with an indeterminate form. You'll apply L'Hopital's rule, and I think you'll see you'll still have an indeterminate form. I mean, yours, I guess they might vary because you're going to have slightly different numbers, but I suspect they're going to work out the same way mine worked out, where you have to use L'Hopital's rule several times on this second question, unlike this first one where you just use it once. But these are fairly straightforward versions of L'Hopital's rule. In this second one, when you're taking derivatives, make sure you recognize that you have a chain rule here. Although I guess that's not super important. I think you'll get the same answer whether you recognize that or not. Still good habits to make. In this third question, here's another one where you have chain rule when you're taking derivatives. And here it'll be a little bit more important. You'll get the wrong answer if you don't properly apply the chain rule here. Whereas up here, coincidentally, you'll get the right answer even if you mess up your chain rule. So be careful. I guess what I'm trying to say is the derivative sine of 2x is not cosine of 2x. There's more to it than that. If you don't know what I mean, ask me. I can help you with that. This fourth question, sine of 4x over tangent of 12x. So we're dealing with trig functions here. Again, you're going to have chain rule when you're taking derivatives. And you'll take derivatives because I think you'll find that this is an indeterminate form, what you're given here. Another comment here, when I see tangent of 12x, I immediately think tangent's the same as sine over cosine. So tangent of 12x is sine of 12x over cosine of 12x. And while that's true, I think that won't really help you in this problem. Because while you could rewrite this as sine of 12x over cosine of 12x and then flip things upside down and you'll have a sine of 4x on the top and a sine of 12x on the bottom, there's nothing you can do with those two signs. They don't cancel out at all because their arguments are different, 4x and 12x. So I think it's easiest just to leave this in this form, not to try to do any trig simplification. When you leave it in this form, you'll need to know that the derivative of tangent of x is secant squared of x. So maybe with that knowledge, you can figure out the derivative of tangent of 12x. And when you get secant squared, that might be hard for you to deal with, but remember that secant of x is the same as 1 over cosine of x. And I know that it's a little bit intimidating to have all these trig identities memorized. I'm not going to test you a whole lot on the trig identities, and I think as you work through some problems, you'll start to just remember them accidentally. You'll accidentally memorize them. But before I put any trig identities on any tests, I'll warn you ahead of time, or I'll give you a little cheat sheet or something like that. Anyways, moving on. Question 5, you don't see a fraction. You're like, oh, this is this different type of problem. These are harder. Right, we have multiplication here. I think you'll find that you have an indeterminate form. But you can't apply L'Hopital's rule when it's written in this form. You have to rewrite it so it kind of looks like a fraction here. The trick for doing so is recognizing, one trick for doing so is recognizing that secant of x is the same as 1 over cosine of x. So with that knowledge, maybe you can rewrite secant of 9x. Secant is the reciprocal of cosine. Question 6 is kind of like question 5 in that you have multiplication going on. You don't have a fraction. So what you have to do is rewrite this so it looks like a fraction, maybe by taking one of the two factors, either x or natural log of x, and raising it to the negative 1 power. I think one of those choices will make your life a lot easier. Question 7 is a little bit different here. This is where you have the subtraction case, so I think it's the infinity minus infinity case that we're dealing with here. But what you'll see is this problem is doable if you change it into multiplication. Because if you can change it into multiplication, you can then change it into a fraction and evaluate it with L'Hopital's rule. And the way you'll change this into multiplication is recognizing that you have an x in both terms. So maybe factor out an x or 2x if you prefer. It doesn't matter which way you go. And then once you do that, you have multiplication, and you can rewrite that as a fraction using that to the negative 1 power trick that I kind of talked about in question 6 and described in the videos. That's the idea for question 7. Question 8, 9, and 10 are all kind of the same flavor. You see these exponents here. And when you see exponents with variables in them, that's the third type of indeterminate form, the third class, I guess, of indeterminate form. What you're going to do on all of these problems is involve natural logs. So for the first one, start out by naming this thing. Y is the question that's asked. And then take the natural log of both sides And as I mentioned in the videos, you can interchange limits and logs. And now maybe you can use some log rules to get rid of this exponent and rewrite this as multiplication. And then you can do a whole bunch more steps involving L'Hopital's rule to get an answer here. But then when you get that answer, be careful, recognize that that's not the answer to the question. That's the answer to the natural log of y. The answer to y is the question. So your answer will be y, which will be e raised up to some power, and that power is kind of the answer you got up here. Hopefully that makes sense. If that doesn't make sense, go back and review the videos, because I think you'll see that I did several examples that are kind of like this. And you'll do that for both 8, 9, and 10. So you'll do that several times in this homework. And that'll bring you to question 11, which is the extra credit one. This question's really hard. I don't know. If you really like L'Hopital's rule, if you want practice with derivatives and stuff, you can do it. If not, feel free to skip it. The hint that I want to give you is this, that the square root of x squared times a bunch of stuff is the same as x times the square root of a whole bunch of stuff. You can take this x squared that's underneath the radical and move it outside of the radical if you take its square root. And you're like, whoa, wait, what? Why would you do all this? Why would you think to do all this? Well, the idea is I have this subtraction going on here. I have an infinity minus infinity subtraction case. So what I want to do is factor something out so that I can write it as multiplication. Because if I can write it as multiplication, then I can rewrite it as a fraction by taking one of those factors and raising it to the negative 1 power and putting it down in the denominator. So that'll be the overall strategy that we have for this problem. But if you look at this, you're like, well, how can I write this as multiplication? One of them has a radical and one of them doesn't. Well, here's the trick, right? If you can rewrite the radical so that it's x times something else, now you can factor out an x from each of your two terms, and that will allow you to rewrite this as multiplication. If that makes sense, that's how you start this problem. If that doesn't make sense, send me an email or something, show me where you're getting stuck, or just skip it because, again, this is the extra credit question.